Hello everyone, we're doing 2.4, the cross product. So we learned vector operation, addition, subtraction, and scalar multiplication, and dot product, and today cross product, okay? All right, so before introduce cross product, let me introduce you 2 by 2 determinant and 3 by 3 determinant first. So let's talk about this. 2 by 2. Determinant. Okay, so we read 2 by 2. Okay, so normally these two using row, these two using column. Okay, so in general, we have the form of 2 by 2 is like this. So a sub 1, a sub 2, b sub 1, b sub 2. Okay, then what is 4, right? So we do calculate 2 by 2 determinant. So we multiply this way. So that means a sub 1 times b sub 2. Then we take away and multiply this way. So a sub 2, b sub 1. Okay, so let's do example. Find 2 by 2 determinant. So that will be 3, negative 2, 5, 1. All right, then how do we find 2 by 2 determinant? So we multiply this way, right? So 3 times 1, answer 3 times 1 minus negative 2 times 5. Then what do you get? We get 13? Good job. All right. How about what if we have 3 by 3 determinant? So let's see. Three by three determinant. So read 3 by 3. Okay. So same. This is a row. This is a column. So let's denote this way. A sub 1, A sub 2, A sub 3. There is a row, right? B sub 1, B sub 2, B sub 3. There's a second row. C sub 1, C sub 2, C sub 3. There's the third row, right? And then this is a column, right? A sub 1, B sub 1, C sub 1. That's the first column, second column, third column, right? Okay. In that case, how do we calculate? We calculate the first row as a factor. So that will be A sub 1. Then if we take out, if we factor out A sub 1, then we are using only this number. So take out this one. So we are using only this number. Yeah. So there will be B sub 2, B sub 3, C sub 2, C sub 3. And then that will be, hold on 1 second. So that will be positive, negative, positive. Yeah. And then we always look, and that is negative, positive, negative, positive, negative, positive. Yeah. So we will not use the below numbers as a positive, negative, positive, but I just want to telling you the sign. So first one, positives, always start the positive, negative, positive, negative, positive, negative, positive. Okay? So a sub 1 is positive. So normally we don't put the positive, right? And second one is a sub 2 negative. And then third one is a sub 3 is positive, right? Okay, for consistent, so let me make the same color. Okay, then a sub 2, we factor out a sub 2, then we are using this number. Make sense? So that will be a sub 2, so b sub 1, b sub 3, c sub 1, c sub 3. Make sense? Okay, now we factor out a sub 3, then we are using only this number. So that will be b sub 1, b sub 2, c sub 1, c sub 2. Yeah. All right. Now we know how to calculate determinant of 2 2 by 2, right? Yeah. So then we can do that, right? So that will be a sub 1. So multiply this way. So b sub 2, c sub 3 minus b sub 3, c sub 2. And minus a sub 2 multiply b sub 1, c sub 3 minus b sub 3, c sub 1. So if you get confused which one multiply first, I am right-handed, so this one first, right? So like that, diagonally, right hand. Yeah. Okay, so then a sub 3, b sub 1, c sub 2 minus b sub 2, c sub 1. Yeah. Okay, let's find find 3 by 3 determinant. So that will be 2, 5, negative 1, negative 1, 1, 3, negative 2, 3, 4. Positive, negative, positive, right? So we need only that sign. We don't need the rest. Then we factor out with 2, negative 5 plus negative 1, right? Okay, then if we factor out with 2, then we are using only this number. So 1, 1, 3, 3, 4. Then negative 5. If we factor out with the negative 5, then we are using only this number, right? So that will be negative 1, 3, negative 2, 4. Now, if we are using this number, then if we factor out with this number, then we are using only this number, right? So that will be negative 1, positive 1, negative 2, 3. Okay, let's calculate. So we calculate it this way. 2 times 1 times 4 minus 3 times 3. Yeah? Minus 5 Negative 1 times 4 minus 3 times negative 2. Negative 1. Negative 1 times 3 minus 1 times negative 2. Okay, now there will be 2 times negative 5, negative 5, and inside this will be positive 2, and negative 1, inside will be negative 1. Okay, can you please calculate? What do you get? Negative 19, very good. Okay, now let me write down, actually copy and paste the cross product. Okay, so this is a cross product. We have two vectors, u and v has component. Then cross product, we are using this notation, right? So it's like a multiplication notation, but this is a cross product. So we can use cross product of u and v. With cross product of vector u and vector v, right? Okay, then look, we have I, J, K, we denote like standard unit vector, right? And then U sub 1, so we put their component here, right? Okay, now instead of we take out all the first row earlier, right? We take out in the back, so I, J, K, right? And then their component. So look, we factor out, then we are using this number, right? So u sub 2, u sub 3, v sub 2, v sub 3 is here. Now, we factor out j, then we are using only this number. So that's a u sub 1, u sub 3, v sub 1, v sub 3, right? Okay, so we knew that that's also positive, negative, positive, right? Okay, the last one, we factor out with the k hat, then, sorry, k hat, then we are using only this, right? U sub 1, U sub 2, V sub 1, V sub 2, right? Now we know how to calculate 2 by 2 determinant, right? So this is the one. U sub 2 multiply this, minus multiply that, right? Multiply this, minus multiply that. Multiply this, subtract that, right? Okay, let's do example. So we have a P, which is negative 1, 2, 5. We have a Q. My Q looks like this, right? 4, 0, negative 3. Find the cross product of P and Q. Okay, so let's do it. So we have I, J, K, right? Now, negative 1, 2, 5. Is it too much? I, J, K, 2, 5, 4, 0, negative 3. Yeah, my handwriting's big. Oh, okay. Then, I minus J plus K, right? Okay, we're using only this number. So let's do it. copy, paste. Good. And then J, we are leaving, we are using this number, right? So that will be -1, 5, 4, -3. So if I make a mistake, please let me know. And then K, oh, K, sorry. No, K. Okay, so we are using this number. Too big. Oh, there is negative, huh? I did not know that. Okay, let's calculate. So we multiply this way. So 2 times -3 minus 0 locally. And -1 times -3 minus 5 times 4 and J. And plus 0 minus 2 times 4 K, right? Okay. What do you get? We have a -6I plus 17J minus 8K. Yeah. So we have a vector. Make sense? So we had number 2 by 2 determinant, 3 by 3 determinant. We have a number, right? Earlier. Yeah. 13. But then cross product actually gives us the vector, right? But we are using same processing with the 2 by 2 determinant, 3 by 3 determinant method, right? So cross product gives us the vector. -6i, 17j, -8k. Okay. Um, let's calculate QMP. How about cross product of QMP? Oh, no. Okay. All right, so find Q by P. So that will be I, J, K, -1. Sorry, this P, Q, right? So 4, 0, -3, -1, 2, 5, right? Yeah, I want to do Q first. All right, then I, J, K, right? All right, so we, oh, pointing. Yeah. We factor with I. That means we are using this number, this vector. Okay. Yeah, not number, right? Vector. If we are using J, then we are using this vector. So 4, -3, -1, 5. If we are using K, we are using this number. All right, so let's calculate 0 minus -3 times 2 I minus 4 times 5 -3 times -1 J plus 4 times 2 minus J as 0 K. Okay, so there's a positive 6I minus, and then it's a negative, negative, positive, negative. So negative 17J, right? And then positive 8K. Yeah. Okay. Now, what can we tell? Can you see that? This is P cross product of P with Q. This one cross product with Q and P, right? So what can you tell? Only the sign difference, right? All right. Then we can say that, do you agree this? So we have P cross product of P and Q is the same as, how do you make the same? Negative, right? Q cross product with P. Yeah. Makes sense? Okay. Um, let me copy and paste the one picture here so that I can explain to you. Where's my cursor here? Okay. Okay, so I did not copy and paste the graph, but I just copy and paste from the previous numbers, not numbers, vectors of P and Q, right? And we just did that, the cross product of P and Q and cross product of Q and P, right? Okay, this is a standard unit vector form, right? I want to express as a vector component, then that will be -6, 17, -8. That will be 6, -17, 8. Yeah, okay. Let me draw. So that will be Z. And that will be X. That will be Y. Okay. Oh, you cannot see well. Yeah, it's okay, right? All right, so I forgot to mention about the right hand rule. So this is Z, this is X, and then that folding the fingers will be Y. Yeah. So Z, X, this is X. Yeah. And this will be, inside will be Y. Yeah. Okay. I want to plot the point, the vector -1 to 5, which is P. So let's do it. -1, right? And 2, 5. So I want to make a parallel with y-axis. Okay, so -1, 2. So 1, 2, right? And then 5. How do you draw the 5? From here, parallel with Z, right? So that will be 1, 2, 3, 4, 5. That will be P. Negative 1, 2, 5. Make sense? Okay. Mm. 1, 2. 1, 2, 3, 4, 5. So this is P. Q. 4, 0, negative 3, right? Q. 4. So let's see. 1, 2, 3, 4, and 0, and negative 3. From here, negative 3, parallel with the z-axis. So 1, 2, 3. That will be Q. So that will be Q. Yeah. Okay. Now I want to plot the point cross product of P and Q. So negative 6 is 17. Ooh, 17, negative 8. Negative 6. So I said that this is 1. I put the too much for the 1. So 1, 2, 3, 4, 5, 6. Okay. And 17, 17. Parallel with the y-axis. Is it parallel? No. Mm, 17 is 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, too far. 17. Just make approximate to 17. Then negative 8. Way in the bottom, right? So I'm not sure, but let's just make an approximate. Yeah. So there will be cross product of P and Q. Okay. Now let me plot the point. Q cross over P. And I want to make a pause for the recording. Okay, so I made approximately cross product of Q and P here. So let me erase it a little bit. Okay, so can you see that this is a vector P and this is a vector Q and this is cross product of P and Q. Oh, you cannot see, sorry. There we go, yeah. And then this is cross product of Q and P. Can you see that? All right, so little bit mess. So let me erase a little bit. Oh, okay. Okay, now what can you see that? Yeah. Can you see? Let me write down. Can you see that cross product of P and Q is orthogonal to U and V? I'm sorry, not to U and V. P and Q. Sorry, P and Q. And can you see that Q cross Q cross product of P is also orthogonal to P and Q, right? Orthogonal means perpendicular. Perpendicular. Yeah, so let me write down. Can you see cross product of P and Q orthogonal to P and Q? Yeah, here. Also, can you see that cross product of Q and P orthogonal to P and Q, right? Yeah. So let me do notation like a perpendicular notation. Yeah. Make sense? Okay, now let us do a little bit more about the cross product. I cross product with J, then we get K. And we have J cross product with I. What do you get? Very good. Negative K, right? Good job. Okay, let's do the first one. So we have I cross product with a K. I'm sorry, I cross product with a J. So we have I, J, K, 1, 0, 0, 0, 1, 0. Okay, now I minus J plus K. All right, so I, which is 0, 0, 1, 0, we are using this one. J, 1, 0, 0, 0, K, 1, 0, 0, 1. Okay, so we have 0 minus 0, I, 0 minus 0, J, 1 minus 0, K, which is 1K, right? So 0I minus 0J, not Z, J, plus 1K, which is K. Yeah. That's how they got it, right? K. All right. We have more, but I'm not gonna show you everything. Just say, uh-huh. All right, so we have J cross product with K, which is gives us I. J cross product with J. Did I say J cross product with J? No. K cross product with J. What do you get? Yes, negative. Good job. Negative I, right? Okay, how about this? K cross product with I equal to J. Then what do you get? This one. Ooh, reverse, right? Should be reversed. I cross product with K. Then we get negative J, right? Okay, we can see the pattern there, right? What kind of pattern? If we have a cross product itself, right? We get the zero vector, right? If we have cross product ij, then we get the another one k, and then we know that they change the order, then we get the negative with the same result, right? Jk, what is another one? Is I, right? Ki, what is another one? Is j. Yeah, makes sense? There's a pattern. Okay, now, how about this? Let's make a quick here. Find I cross product with J cross product with K. Okay, now always we have to simplify inside the parentheses. So we have I had there cross product with, what is this? Good job, it's I, right? Because J cross product with K, what is another one is I, we don't see that, so I is there, right? And then same cross product itself, then we get the zero vector. Good job. Okay, so let me bring properties of cross product. Okay, so we have a theorem 2.6 properties of cross product. UV, W are vectors, CB scalar. Then this is not commutative, but if we have negative sign, then they are same result, right? So number one, this is what we just did that earlier, right? Okay, now we have a cross product of U with addition of two vectors. Then we distribute, we get cross product of U and V, addition of cross product of U, W, okay? C is scalar, we have cross product of UV, then this one gives us this C in front of U or in front of V. It can be this way or that way, all right? Okay, now, if we have a zero vector, this is commutative, yeah, because we put the negative sign, still zero, right? Negative zero is zero, positive zero, still zero, right? Okay, we did this one. We have a cross product and itself is zero vector. Okay, now we have a cross product and then we have a dot product. Then this will give us this one, yeah, but that will be cross product, yeah. Then we have a dot product at the end. But I'm gonna show you this one later with the numbers. Numbers means vectors, yeah. Instead of all the letters, right? Okay, now we have magnitude of cross product. So last time we are using dot product related with the cosine, right? The magnitude of cross product related with the sine. So let me bring here. Okay, so this is a theorem 2.7 magnitude of cross product. U and V are vectors, theta is the angle. Then we have a magnitude of a cross product of U and V. Then we have magnitude of U, magnitude of V, and sine theta, right? Yeah. Please read the proof if you are curious how you get this one, right? In the textbook. Okay, now we have an example. Find magnitude of cross product of two vectors. Okay, now we are using that formula. Magnitude of cross product, right? Okay, now we get just a 4 squared, right? And we get negative 3 squared, right? Then sine, we are using 90 degree. In that case, because we knew that, let me write down. In that case, here, theta equal to 90 degree, since vector u cross v is orthogonal to u v. All right. Okay, so what is the sine 90 degree? It's 1. Good job. So we get 4 times 3 times 1. So we have a 12. Make sense? Okay. So let me draw. This is Z, this is the X, this is Y. 0, 4, 0, 4, 0. This is the vector U. And 0, 0, negative 3, right? So this is vector V. Yeah. Maybe just for fun, maybe we want to find out U cross V. Just check, right? Check. U cross V, I, J, K. Just know what's going on, right? So U 0, 4, 0, 0, 0, negative 3. So I, J, K, right? So I 4, 0, 0, negative 3. J 0, 0, 0, negative 3. And K 0, 4, 0, 0, right? So we have negative 12 and 0, and 0. Yeah. So it's a negative 12. Negative 12. So looks like here, right? So that will be U cross V. Yep. So the perpendicular with U and perpendicular with V. Yep. Okay. Now, let me copy other question here. Okay, so we have two vectors, A and B, and they say they find unit vector orthogonal to A and B. Yeah. Okay. So we knew that A cross B cross product, actually, A cross product of B is orthogonal to A and B, right? Okay, then unit vector, how did we find unit vector before, right? So you had equal to 1 over magnitude of vector V times vector V, right? Then A cross B, A cross, I'm sorry, A cross product of B orthogonal to A and B. So we just following same form, okay? So we want to find the unit vector orthogonal to that, right? So you had, then we know that orthogonal to, so that means A cross B, right? To orthogonal to there. So then we're following this formula. So magnitude of that and A cross B. Yeah, make sense? Okay, let's do it. We want to find cross product first. So A cross product of B, which is I, J, K, and we have 5, 2, -1, 0, -1, 4. Okay, now I, J, K, right? Okay, we're using these vectors, vector component. So this is vector component. Copy. And J, we are using this vector component. And K, we are using this vector component. Yeah, okay. Now we will do that. 2 times 4 minus -1 times -1. I had. And we have 5 times 4 minus 0. J hat. And we have 5 times -1 minus 0. Luckily, we have a 0, right? Okay. So I, we get 7I, J, we get 20J, and K, 5K. Yeah. All right. Now, we want to find the unit vector. Copy. Oh, why? Oh. Delete. Okay, let me just write down. So you have unit vector. In the case, orthogonal, unit vector orthogonal to A and B. So 1 over magnitude of cross product of A and B and cross product of A and B, right? Okay. Now cross product of, so that is cross product of A and B, right? So we get magnitude. So 7 squared plus 20 squared plus -5 squared, right? 1 over that and cross product. So 7i plus 20j minus 5k. So this is not vector component form. So we are using parentheses, otherwise a triangle bracket, right? All right, so what do you get this one in the denominator? So we have square root of 474, 7i plus 20j minus 5k. Yeah, so we can just leave it like that. But if we want to express as vector component form, then we can use 7 over square root of 474, 20 over square root of 474, and -5 over square root of 474, right? That's a vector component form. Yeah. Okay. Okay, now let's talk about area of parallelogram. Data 2.8 area of parallelogram. Okay, so yeah, looks like a parallelogram. Okay, let's make a vector. This is a U, this is a V, right? Okay, previously we used vector V here and vector we're using this is X, this is Y, right? Normally V as R, right? And then X equal to, we are using vector, the magnitude of vector V cosine theta, Y equal to magnitude of V sine theta, right? So we are doing this one every time, right? Okay, now then, this is the height, yeah? So we're using magnitude of vector V sine theta, right? So here too, we are using height. So magnitude of vector V sine theta, yeah? Then area of parallelogram is base times height, right? Okay, so what is the base? Base is this one, right? But then we talk about only the length. So that will be magnitude of a vector U. And what about the height? Height will be magnitude of vector V sine theta, right? We've seen this one before. Yeah, good job. So it's a cross product of U and V with the magnitude, right? So just up there. So that will be magnitude of U cross over V. Yeah. Okay. Let's do this one. Let me copy the questions. Okay, let me just copy. Let me pause first. Okay, so we have 3 points here, vertices of a triangle. Find its area. All right. Uh, we're gonna find the area of parallelogram. Then we can find the area of a triangle, right? So actually the parallelogram, we can split two, right? There's the one triangle, there's another triangle, right? So basically we find area of a parallelogram by using the formula, right? Then we divide by 2 later on. That will be triangle, area of a triangle. Make sense? Yeah, that's why the formula of a triangle come from the area of parallelogram. Yeah. Okay, let's do it. Ooh, what's going on? Okay, finding, note, finding the area of parallelogram. Okay, so let's find out the vectors because this is the vertex, yeah, only the point. Let's find the vector. How do you find the vector? So let's make a P R. Let's find out PQ. Yeah. Okay, so that means this is initial, this is terminal. This is initial, this is terminal, right? So that's how we make a vector, right? So 0 minus 1, 1 minus 0, 0 minus 0, right? What do you get? We get negative 1, 0, 1. And this will be Q. Oh, I was using Q earlier. Sorry about that. This is Q. No, I don't want to get confused. So R, 0 minus 1, 0 minus 0, 1 minus 0. Yeah, negative 1, 0, 1. PQ, I just did, did. Hold on. 0 minus 1, 1 minus 0, 0 minus 0. That will be negative 1, 1, 0, right? Okay, let's make a cross product with the two vectors I, J, K, negative 1, 0, 1, negative 1, 1, 0. Okay, I, J, K, right? So I, 0, 1, 1, 0, J, negative 1, 1, negative 1, 0, K, negative 1, 0, negative 1, 1, right? Okay. 0 minus 1, 0 minus negative 1, negative 1 minus 0. So we get negative I minus J because negative negative is positive, negative, right? And negative K. Yeah, don't worry, we're gonna have a magnitude, right? So magnitude of PR cross product with PQ. So that will be -1 squared plus -1 squared plus -1 squared. We get square root over 3, right? So then area of triangle, this is square root over 3 over 2. Yeah. So that's 0.866. Is it correct? Okay. And book did, textbook did, the text. PQ cross product with the PR because it's magnitude, right? So it's magnitude. So they make a negative is positive, right? That's why same answer. Give it to the same answer. Okay. All right. Now, I said that earlier, one of the properties, and then I said, oh, I'm gonna show you later with the numbers. Numbers means the vectors, right? So I'm gonna tell you about the properties right now. Okay, so triple scalar product of vectors. So we have a dot product with the cross product of V and W, right? So if we have this, then they say that this is the same as you cross a product with a V with the dot product of W, right? So let me write down and dot product with the W, right? Okay, so I'm gonna show you with a example so that we understand this triple scalar product. All right? Okay, so U equal to 1, 3, 5. V equal to 2, -1, 0. W equal to -3, 0, -1. So find U dot with a V cross with a W and U cross V dot product with W, right? Okay, the first one. So U dot V cross product with W. Okay, so this one we can use like that, okay? So instead of IJK, we are using just the vectors, yeah? Vector components here, yeah? So there will be, instead of IJK, we are using U, 1, 3, 5, and 2, -1, 0, -3, 0, -1. Okay, then plus, minus, plus, right? All right, so we factor out with 1. So it's okay we factor out with it at the end, like IJK, right? But we can factor out with the first, like 1, right? And then -3 and +5. Okay, so if we factor out that, that's a negative 1, 0, 0, negative 1. If we factor out negative 3, 2, 0, negative 3, negative 1. If we factor with a positive 5, then we have 2, negative 1, negative 3 is 0. Okay, so that will be multiply this way. So 1 minus 0, minus 3, negative 2 minus 0, and times 3, right? Okay, so we get, with the calculate, 1 plus 6 minus 15, which is, what do you get? Negative 8. Good job. Okay, let's do other one. So I want to do U cross V, dot product with W, right? So this one we can express as like IJK, right? So we call this a triple scalar product because cross product, dot product there, right? Okay, so you, yeah, we don't have to do anything. 135 to negative 1, 0. Yeah. And negative 3, 0, 1. So it's a same thing. All right. 135 to negative 1, 0, negative 3, 0, negative 1. Same as earlier. But then we factor out with all these numbers, right? But now we will factor out with this number. It's different. Okay? So that will be negative 3. So let's make that positive, negative, positive, negative, positive, negative, positive, negative, positive. Yeah? Same, right? Positive, negative, positive, negative, positive. Like earlier, same, right? So we will do negative 3, 0, negative 1, right? Okay, so that will be 3, then 3, 5, negative 1, 0, minus, and um, everything will be 0, right? So we don't need actually this one. So don't bother about that, right? And there will be minus 1. We get 1, 3, 2, negative 1, yeah? Okay. Hopefully. Let me do 1, 3, 2, negative 1. So that will be negative 3, 0 minus 5 times negative 1. And minus 1, negative 1, minus 6. Okay, that will be negative 15 plus 7, which is negative 8. Yeah. Okay, then Can we see this is negative 8? Also, this is negative 8. We get the same answer, right? Yeah. But we knew that cross product is not commutative, right? But we know dot product is commutative. Yeah. We have a dot product and this one. We have a dot product with this one. Yes. So dot product is more stronger in that case. So, so let me write down note. We get the dot product with cross product with V and W. So U cross V dot product with the W, right? Note dot product is commutative. Cross product is not commutative. So that is we had earlier, right? Same as V cross product with V, U, right? Okay. Almost done. Hanging there. All right, so here we have a theorem 2.10, a volume of a parallel pipe. So we just learned that area of parallelogram. So we talk about the area in 2 dimensions, and the volume we talk about in 3 dimensions, right? Okay, so then volume we have the formula, which is U dot product with V cross V cross product with W, right? Now we're gonna have an absolute value because we don't want the negative as a volume, right? Okay. We just learned that triple scalar product produce a scalar. So we did the problems. We have 18, right? Oh, negative 8, negative 8, negative 8, negative 8, right? So it's a scalar, right? It's a scalar, gives us a scalar. Now, since this is a 3 dimension, so we called parallel pipe, right? So this is a vector U, this is a vector W. Then there is the red vector that will be projection of vector U onto V cross W. So this is the one. Then this will be height. This will be height. Yeah. So height should be this is the height. Yeah. Okay. Then they say the height of a parallel pipe is given by magnitude. Yeah. We talk about the length. Yeah. So we take the magnitude, right? Okay. Let me prove this one, how we get the volume formula like this. All right. Okay. So previously we had magnitude. We have a magnitude of a projection of vector V onto U, right? Then we get dot product of UV over magnitude of U. Okay, then let's just follow this formula by using projection of vector u onto vector cross product of v and w, right? Okay, uv will be, I just follow that v cross product with w, then u, yeah? Just following this one with a different notation, yeah? Make sense? Okay. Over the denominator, u, so there will be same as this one in the case. Yeah. Okay. Now, what is the formula of volume in general, right? So we have length times width times height, right? Almost done. So there will be length times width times height. Okay, then in other words, we can say that height and times area of parallelogram, right? Okay, then height, we talked earlier. Height of the parallel pipe is given by that, right? The magnitude of the projection, right? So there will be magnitude, magnitude of projection of vector u onto cross product of v and w. What's the area of a parallelogram? We had earlier, can you see? In that case, v cross magnitude of v cross product with w, right? Okay, now, then I want to replace magnitude of projection of u onto cross product of v and w. So with this one, and then we have cross product of v and w with magnitude, right? Okay, we can simplify. Then this is the formula we have. Yeah, can you see that? So u dot product with cross product of v and w. So we have this one, right? So I can just change that because dot product is commutative. We can use that, right? And then we will use the absolute value because we don't want the negative as volume, right? Dot product. Commutative. Okay, we're done. One more example. Yeah, cross product. We want to find the volume of parallel pipe. All right? Okay. So we have vector u, vector v, vector w, negative 2. Find the volume of parallel pipe with adjacent edges. U, V, and W. Okay, so volume, we had the formula U dot product with cross product of V and W, right? So we call this a triple scalar product, right? With the absolute value, right? Okay, that means we can just using cross product method, right? Instead of ijk, we are using just a component of a vector u. So -1, -2, 1, 4, 3, 2, 0, -5, -2. Okay, so we factor out with those numbers. And plus, minus, plus, right? Okay, so we get -1 and -2, +1, right? So negative, so 3, 2, -5, -2, -2, 4, 2, 0, -2, +1, 4, 3, 0, -5. Please check those numbers. Check it out. Yeah. All right. So calculate. So we have a -1, -6, -10, +2, -8, 0, 1, ignore 1. So we have -20 minus 0. Yeah. Okay. So we have -4 and -16 minus 20. We have to have an absolute value, right? So this is actually absolute value. So we have to have absolute value, right? So we get -40, which is +40, right? I'm very sorry. We have one more. Sorry about that. Okay, let me bring the definition and then one more question. Okay, so this is important to why we are doing cross product, right? So one application. Thank you for your patience. Okay, so we have a definition, torque. So, oh, let me delete it later. Torque, we are using normally we are using the first letter T, right? But this one looks like T, but we read tau, the Greek letter. So measures tendency of a force to produce rotation about axis of rotation. Okay, basically you set up the IKEA stuff, furniture, right? So you are using wrench and bolt. So you make it tighten the bolt, right? So we are using torque. So twisting effect by force. Yeah. So I wrote down there, wrench to tighten a bolt, right? So tau, which is equal to, we just learned that cross product. So cross product of R, or, what's the R in the case? It's a vector with an initial point. And also F, we learned the last time, it's about the force, okay? Okay, now we do evaluating torque. So a bolt is tightened by applying force 6, and this is the Newton, the unit. To 0.15 meter range. This is a range, right? And the angle between the range and the force vector is 40 degrees. Find the magnitude of torque about the center of the bolt. Okay, so magnitude, then we take the magnitude of torque. So we have torque equal to cross product of that, right? So they are vector. So this is also vector, torque. And then this is the magnitude. So we take the magnitude, right? This notation. Okay, now we don't do that cross product because we don't have that information. We have information about the angle, right? Then, does anyone knows that? What kind of formula we are using it? Very good. So we are using this formula. Yeah. So we have earlier magnitude of U cross over V, which is magnitude of U, magnitude of V, and sine theta, right? Okay, then we're done. So just to substitute. So what's the R initial point? That is a 0.15 meters, right? And then the force, there is a force of 6N, right? So this is a 6N Newton. And sine, what kind of sine? Degree, yeah, it's a degree, 40 degree, right? Okay, so if we calculate everything, we get 0.58 mn or nm, same, right? So meter Newton, okay? And meter Newton, we're using joule. Oh, here. So we have a 0.58 J, which is joules. All right. Any question? Thank you for watching. I will see you in the next section. Thank you. Bye-bye.